Here we are with lesson 3.6, which covers arithmetic sequences. You should have some previous knowledge of this because I had you SQ3R it. So let's first start out with talking about what our learning goals should be in this lesson. The first learning goal should be that you can recognize and be able to extend an arithmetic sequence. And the other objective, finding a given term of an arithmetic sequence. So if I asked you to find the 100th term of a sequence, what's a method we could use to do that? So let's first of all start out with, what are we talking about when we talk about a sequence? A sequence is any list of numbers. But a sequence does not have to be an arithmetic sequence. There are different types of sequences. We're going to study arithmetic sequences in this lesson. So our first thing we're going to do here, it says, is the following sequence an arithmetic sequence? To be an arithmetic sequence, we have to have, when you go from one term to the next term, there has to be what we call a common difference. Or in other words, between successive terms, it either continues to increase by the same amount or decrease by the same amount. So how we're going to show work for this is we would say to get from -3/4 to -1/4, we have to add 2/4. To get from -1/4 to +1/4, it goes up 2/4 also. To go from 1/4 to 3/4, again, it increases, goes up by 2/4. So we would call this an arithmetic sequence because between successive terms, we have a common difference of 2/4. So we're going to say yes. And when we say yes, that means it has a common difference, we're going to call D. We're going to say that D equals 2/4, or simplified, we could say 1/2. Okay, moving on to the second one. Let's check to see if this one is an arithmetic sequence. To go from -4 to -2, we go up 2, plus 2. To go from -2 to 1, that goes up 3. We'll just finish here, even though it's already proven not to be. Go from 1 to 5, add 4. This is a different type of sequence. We could not say that this was an arithmetic sequence. We would say no common. In other words, it isn't the same each time. No common difference. So that's some of what you're going to be doing, is determining if a sequence, a list of numbers, can be considered an arithmetic sequence. And if it is, what is its common difference? What is its D value? Okay, what if we have to find more terms for an arithmetic sequence? When we need to find more terms for an arithmetic sequence, we're going to add the common difference to the previous term. So if you want the next term of an arithmetic sequence, you look at the previous term and you say, what is that? Add to it your D value, your common difference, and you will have the next term. So when we have an A sub n right here, this is an algebraic model for finding more terms of the arithmetic sequence. A sub n is actually the term you're looking for. So the term you are looking for. So such as up above in our number one, where we have an arithmetic sequence. If we were going to get the next term of that one, we would be looking for the fifth term, because we were given 1, 2, 3, 4 terms of it. The next term would be considered the fifth term. So in that case, we'd be looking for a sub 5. We're just showing that we're looking for the fifth term. That n tells us, a sub n tells us which term we're looking for. Well, a sub, that subscript, n minus 1 is the previous term. If you take 1 away from the term number you're looking for, then that should take you to the previous term. So we have, in that one up above, if I said if we were looking for the fifth term, then the fourth term, the last one that we had, would be the previous one, and 5 take away 1 is 4, so that would be considered the previous term. And D, we already said, is the common difference. So we have all the parts of our model here. A sub n, term we're looking for. A sub n minus 1, the previous term. Add to that the common difference, just what I set up here in this. To find more terms, add the common difference to the previous term. So, even though I won't make you sub into that model, I want you to just start having an understanding of being able to talk about it algebraically that way, because we are going to use a model later on in our notes that you should have used in your SQ3R. So find the next 4 terms of the following sequence. So first of all, we have to decide what is the common difference. Well, right now, I think it's going to be a little bit more challenging to find it until we rename those. So I'm going to erase my little trying to find it here, and I'm going to rename these first of all as, so they have a common denominator. 8, 4, and 2 are the denominators, so 8 would be a good common denominator. So 3/8 doesn't need to be renamed. 3/4 can be renamed as 6/8. 9/8 doesn't need to be renamed, and 3/2 can be renamed as 12/8. So now we have our arithmetic sequence renamed as eighths, so we can find the common difference easier. So our common difference, to get from 3/8 to 6/8, it goes up 3/8. And that happens between 6/8 and 9/8, same thing. Between 9/8 and 12/8. So our D value is 3/8. So to find the next 3 terms, basically what we do is we keep adding, or next 4 terms, we keep adding that 3/8. So here's what we're going to show. We're going to show that we have 12/8, to which we're going to add 3/8. And what do we get? We get 15/8. 15/8, add 3/8. Previous term, add the common difference, gets you to the next term of your sequence. 18/8, add 3/8. Now we have 21/8. And we need 4 of them, so 21/8 plus 3/8, 24/8. But of course we're going to do what the state that they were in before. They were simplified before, so we're going to simplify any of these that can be simplified. We're not going to necessarily change them to mixed numbers, but if they can be simplified in their improper form, we will. So 15/8 would be the first of our next four terms. That can't be simplified, so we'll just leave it as it is. 18/8, both are divisible by 2, so that can be simplified to 9/4. 21/8, that can't be simplified. And 24/8, that can be, we will make that into the whole number 3. There are our next four terms of that arithmetic sequence. So finding next terms of the sequence. This is the kind of process we need to go through and the kind of work you need to show. Okay, let's move on to see what we're going to do next here. To find a later term, so one further down the road, like remember what I said, what if I want you to find the 100th term? I don't think you want to keep doing what we were just doing, where we knew 4 terms, we found the next 4, so we were only up to 8. We don't want to do that another 92 times to find the 100th one. So how can we do it using a model? So here's our model right here. A sub n, remember we said that is the term you're looking for. So the term you are looking for. So in this case, if I said I wanted you to find the 100th term, it'd be a sub 100. Your n value would be 100. Okay. A sub 1 is the first term, the starting term of your sequence. The first term of sequence. Notice each number in the sequence is called a term. So the first one, the starting one, is a sub 1. N is the number of term you're looking for. Number of term you want, we'll say. So if you want the 100th term, N is 100. And D, we already talked about that also. D is the common difference. Okay, so let's go back up and look at that model. A sub n, that should be the answer you get. What is the answer to, if I'm asking you to find the 100th term, what is it? Okay, that would be the answer you get. A sub 1, well, we have to start somewhere, so our sequence starts somewhere. So we start with the first term, and remember we keep adding on to that. So we're going to add, in parentheses it says n minus 1. Well, we don't want to count that first term again. We're already adding it at the beginning, so we have to take 1 away from which term we want to find. So if we want to find the 100th, the first term is already accounted for, so we really only need to add something 99 times. We wouldn't want to add 99 times, but that's what we would really need to do. So we would take 99 times our common difference so that we wouldn't have to add it, because a shortcut for adding is multiplying. Okay, let's just do some practicing here. Find the 60th term of the following sequence. 11, 5, negative 1, negative 7. They only gave us 4 terms. Don't really want to do what we were doing on the front side of our notes. So we're going to use our model. We need a sub 1, our first term. It's 11. Our n value, so basically what we're doing is we're trying to fill in these, okay? So there's our a sub 1. We need an n value. Our n value is going to be 60 because we want to find the 60th term. And then we have to figure out what our common difference is, our d value. And we're already basically told it's an arithmetic sequence, so we only have to do it one time. What do you have to do to get from 11 to 5? It goes down 6. So our D value is actually a negative 6. Our arithmetic sequence is decreasing rather than increasing. So now we'll just substitute in. We're looking for the 60th term, so a sub 60. Our a sub 1 term is 11 plus, we don't need all 60 times, we don't need to add 60 times, so we take 60, take away 1, because we already had that first term accounted for. And that is going to get multiplied times the common difference, or in other words, 59 times we would be adding negative 6. So we're going to say that we have 11 plus what I just said, 59 times the negative 6. Okay, let's calculate what 59 times negative 6 is. So we have our 11 plus a negative, because it's going to be a positive times a negative. And you should get 354, so a negative 354. So our 60th term, our a sub 60, is whatever 11 plus negative 354 is. That is a negative 343. There's our answer. When you're done, of course, you should always decide, do I have a reasonable answer? We had a decreasing sequence, and this is a lot smaller than the last term we were given, negative 7, so I'm feeling pretty confident about it, because at least it went down. Okay, let's find the 15th term of this arithmetic sequence. This time, they're telling us what the first term is. They're telling us what the common difference is. We don't have to see the sequence, actually. We could make a sequence from this, but let's just use our model. We're looking for the 15th term. So, we are a sub 15. Our a sub 1 is, or in other words, the first term of the sequence is 4 2/10. We're looking for the 15th term, so that's our n. And our d value is 1 4/10. So we're going to do the subtraction first. We're just going to bring everything else along. So we actually have 14. That's going to get multiplied times our common difference of 1 4/10. Bad decimal point. Okay, what is 14 times 1 4/10? Let's bring down our 4 2/10. And our product of the 14 and the 1 4/10 should be 19 6/10. So our a sub 15, our 15th term of the sequence, only knowing the first term and knowing the common difference, we didn't even have a picture of it. We are going to have, for the 15th term, 23 8/10. So because we had a common difference of a positive 1 4/10, and this started at a number smaller than 23 8/10, we can feel good about our answer being reasonable, because with a positive common difference, it should keep going up. And we weren't looking for a term real far down the sequence, we were looking for the 15th one. Okay, now we're going to be on the check it out problem. So you probably already did this in your SQ3R. Let's see how you did on it. Let's practice it together. So page 208, number 3, it's pretty close to the bottom of the page. Each time a truck stops, it drops off 250 pounds of cargo. After stop 1, its cargo weighed 2,000 pounds. How much does the load weigh after stop 6? So it keeps dropping off the same amount. That makes it an arithmetic sequence. It has a common difference. We know what happened after the first stop. That would be our first term. So our a sub 1 is 2,000. That's how much it was after the first stop. That's how much was in the truck. Our N value, we're looking for it after stop 6. So we're really looking for the 6th term of an arithmetic sequence. They dropped off 250 pounds every stop, so that's a negative, this 250. The weight is going down. There's less on the truck after each stop. So now we will substitute into our model. We are looking for the 6th term, a sub 6. Our a sub 1 is 2,000, what we start with. Remember, in parentheses, we do the n minus 1, and we take that times our d value, which is negative 250. So we have 2,000 plus 5 times negative 250. So we have 2,000 plus the product of 5 and negative 250. That should be a negative 1,250. So our a sub 6 is equal to 750, and those are pounds. There's 750 pounds of cargo left on that truck after they have completed their 6th stop. Okay, these are the things that should help you be successful with your homework. Good luck.